Now we're going to talk about molar masses of compounds. It turns out we can work the very same types of compounds we worked in our previous lesson for compounds. The only wrinkle is you have to add up the molar mass of the compound. If you're unsure about the concept of the mole, go back and watch the presentation entitled The Mole before watching this one. And so we want to determine the molar mass of each of these two compounds. And to do that, we just need the masses from the periodic chart, and we'll add up the mass of each molecule, or the mass per mole. Okay, let's look at the molar mass of our chlorine, Cl2. So the molar mass would be 2 times the atomic mass of the chlorine, or 2 times 35.45 grams per mole. That mass comes off the periodic table. Doing the math, we get 70.90 grams per mole. And that would be your answer for part A. For part B, we're going to do the molar mass of a little bit more complex molecule, propane. So it's going to be 3 times the mass of a carbon plus 8 times the mass of a hydrogen. And so you're going to get 3 times 12.01 grams per mole plus 8 times 1.01 grams per mole. When you run that all through on your calculator, you're going to get 44.11 grams per mole. And that would be your answer to the second part. As I said, we will be able to do the same types of calculations with molecules that we did with elements in the last presentation. And so this is very similar to the calculation in the previous presentation, except instead of just carbon atoms, we're looking at propane, C3H8. So number of carbon atoms and 20.0 grams of propane, C3H8. All right, let's look at this next problem. We want to know the number of carbon atoms there are in 20 grams of C3H8. For our convenience, I'm showing the molar mass of C3H8 from the previous example we worked, so we don't need to add it up again. So we're going to have 44.11 grams of C3H8 per 1 mole of C3H8. But there's a wrinkle. I've got 3 carbon atoms per 1 mole. So I need to account for that. So for every 1 mole of C3H8 that I have, I'm going to have 3 moles of carbon atoms. Now, if I just asked for molecules, I would just skip that part and not do that, and then finish the problem. And then for every 1 mole of carbon, there are 6.022 times 10 to the 23rd carbon atoms. And then we can see the grams cancel, the moles of propane cancel, the moles of carbon cancel, leaving us with carbon atoms. And so we're going to run that through our calculator. And we get 8.19 times 10 to the 23rd carbon atoms. And that would be our answer. But we had to account for the fact there were 3 carbon atoms for 1 propane. This last problem, it's going to force us to do Avogadro's number the other way and divide. And you have to make sure the Avogadro's number gets grouped together. Some calculators do some weird things. If you use the E like on our calculator, it'll keep it grouped together. But if you have a different brand of calculator where it has times 10 to the n or something, and you're dividing by Avogadro's number, you're going to make sure it's in parentheses to make sure. Run this through on your calculator and make sure you're getting the right answer. Otherwise, you'll get some obscenely large answer instead of the correct one. All right, let's look at this next problem. We got 7.25 times 10 to the 23rd molecules of P2O5, and we want to calculate how many grams that represents. So first off, I'm going to need the molar mass of P2O5 because we haven't added that one up previously. I've gotten the masses off the periodic table right here for our reference. So it's going to be 2 times phosphorus plus 5 times oxygen. So 2 times 30.97 grams per mole plus 5 times 16 grams per mole. And then you just run that through your calculator. 2 times 30.97 plus 5 times 16. And it ends up being 141.94 grams per mole for the compound. Now that's a means to an end. That's not the answer to our problem. And so we're going to divide by 6.022 times 10 to the 23rd P2O5 molecules, which I'm going to abbreviate for space reasons, per 1 mole, P2O5. And then for every 1 mole P2O5, there's 141.94 grams. And so we can see the molecules cancel, the moles cancel, and we're left with grams of P2O5. So then we want to run that through our calculator, and we get to 3 sig figs 171 grams P2O5. And that would be our answer. But notice the division by Avogadro's number, and you've got to be careful about that.